Hello Gretos. In this video we're going to look at what's called change in momentum, which is delta P. If P is equal to mv, then it stands to reason that if we change the mass or the velocity of an object, then the momentum of that object will also change. So the relationship here, delta P is equal to m delta v, which is equal to the mass multiplied by the final velocity minus the initial velocity of an object. So this is change in velocity, mass multiplied by the change in velocity. For us to find the change in the velocity, we take the final velocity minus the initial velocity of an object. Or we can relate it like this. Delta P is equal to the final momentum minus, which is the same thing as saying mass times the final velocity and minus mass times the initial velocity. So we'll have m v final minus v initial, just like in this expression here. So the SI unit for change in momentum is kgs meters per second. So it's also the same thing as the unit for momentum. We must also remember that change in momentum is a vector quantity. In this example here, we are told that a 4,500 kg truck traveling at 7 meters per second to the east reduces its speed to 3 meters per second. Calculate the truck's change in momentum. So our given info, we have mass, we have the velocity of the object. So this is the initial velocity of our object. Initially it's traveling at 7 meters per second to the east, which is our direction here. It reduces its speed to 3 meters per second. So that's the final velocity. And obviously it's in the same direction, it's also to the east. Calculate the truck's change in momentum. So what you want to find is delta P. Right? So we now have all the information that we need. So choose a positive direction. So let's say taking east as positive. Now I write down my equation. Delta P is equal to m delta v, which is the same thing as m v final minus v initial. So I substitute 4,500 multiplied by the final velocity. Since I took east as positive, it means this velocity is positive. This one is also positive since it's to the east. But this is my final. So I'll say 3 minus 7, which is equal to, calculators here, let's do the math. 4,500 multiplied by 3 minus 7. I should get negative 18,000. So negative 18,000 kgs meters per second. Now since I have negative answer here, my negative sign stands for direction. So I need to rewrite my answer. 18,000 kgs meters per second. And I state the correct direction. So this direction here is to the west, since I took east as positive. So that's the change in the momentum that has occurred when the velocity of the object of the truck changed. One can also decide to take west as positive. So let's see, if we take west as positive, what happens? Taking west as positive, so I write my equation. Delta P is equal to m delta v, which is m v final minus v initial, 4,500 multiplied by, right, so I took west as positive. It means that east is negative. So this one is to the east, so it's negative. This velocity is to the east, so it's also negative. So I'll say my final velocity is negative 3 minus my initial velocity is -7. Okay, that will give me 4,500 multiplied by, so I'm going to have -3 here plus 7, which will give me -4. So let's multiply 4,500 multiplied by -3 plus 7, so I get 18,000. Okay, so my answer is positive 18,000 kgs meters per second. Since my answer is positive, I'll just take the one that I chose as positive there first. So you can see that whether you take east as positive, west as positive, by getting the same answer here. Let's look at example number 2. A ball of mass 120 grams hits a wall at a velocity of 12 meters per second. So I have the mass of my object. It travels towards the wall at 12 meters per second. So this is the initial velocity, and bounces off that wall at a velocity of 8 meters per second. So this is the final velocity. Determine the change in the momentum of the object. So I'm looking for delta P. Right, so here's the scenario here that we have. Okay, now let's solve the problem. We need to choose a positive direction. This velocity here is to the right, this one is to the left. So I can choose and say taking right as positive. Okay, so it means that this velocity here is positive, this one is negative since it's to the left. Delta P is equal to m v final minus v initial. The mass is in grams, so I need to change this one to kgs. I simply divide by 1,000, so that gives me 0.12 multiplied by final velocity is -8. I'm looking at this here, minus the initial velocity is positive, right? So what we have, 0.12 multiplied by -8 minus 12. That gives me -2.4 kgs meters per second. So which means our change in momentum is 2.4 kgs meters per second to the left, since my answer is negative. Alright, you can also decide to take right as positive. So let's see what happens. You take right as positive. Alright, taking left, so let's take left as positive. Our delta P is equal to m v final minus v initial. Our mass 0.12. Our final velocity now is positive, the initial is negative. So we have 8 minus -12. That will give us a positive here in the, so I'm going to say 0.12 multiplied by 8 minus -12. That's positive. Oopsie. So I'm getting 2.4 kgs meters per second. So my answer is positive, meaning that it's to the left, according to what I've chosen as positive. So we're done with example number 2. Very interesting. Let's have a third example here. In this example, we're told that a 3,200 kg car, that's the mass, is traveling at 110 kilometers per hour. That's our velocity, initial velocity. It collides with a barrier during a crash test and comes to a halt. So our car actually comes to a stop here. This is the final velocity, which is 0 meters per second. Determine the change in momentum of the object due to the collision. Alright, so now we're not told whether it's going to the left or the right, so we can simply say direction of motion. We're just taking the direction of motion as positive. I can say take the original direction as positive. Fine. So delta P is equal to m v final minus v initial. Our mass is 3,200 kgs, but our final velocity is in kilometers per hour. So we need to change this kilometers per hour. How do you convert kilometers per hour to meters per second? You simply divide this by 3.6. So we say 110 divided by 3.6. And if you do that, you will have converted to meters per second. So 110 divided by 3.6. That gives us 30.56. So we say 30.556 meters per second. So that's our initial velocity. Our final velocity, however, is 0. So we say 0 here minus 30.556. Alright. So 3200 multiplied by 0 minus 30.556. I'm getting negative 9779.2. That's kgs meters per second, which is equal to 9779.2 kgs meters per second, and the original direction or the direction. And this is how we find the change in momentum of an object.